So we're going to talk about the product rule. And if you remember that the product rule says for any product u of x that is equal to two functions multiplied together, whether that be x sine x or x squared times e to the x. I tried to do something that I couldn't simplify. So if I say, hey, so then we know that this is the product rule, u prime of x equals f of x times g prime of x plus f prime of x times g of x. So if I say that k of x is f of x times g of x, I can't in general find k prime of x based on what I have, because I don't know what those functions are, but I can find k prime of 2. That'll be f of 2 times g prime of 2 plus f prime of 2 times g of 2. That makes sense so far? So now I just need to look at the graph and get f of 2. That's 2. G prime of 2 is 1. Remember, I'm getting the y coordinates from these. F prime of 2 is negative 2. G of 2 is 3. This is 2 plus negative 6 is negative 4. That makes sense? You will have one like that on your review and one like that on your final. That's all there is to that.
Oh, good.
You're like, okay, that sounded bad, but it's not bad. You just have to actually remember to use the product rule and then just take your numbers off the graphs that are given to you. Curve sketching. This is a good opportunity to review. So we're going to do number 1. And over here I have the worksheets. So it tells us to find about everything. Okay. So x and y intercepts. This is effectively factor. Well, y-intercept is 0. So x-intercepts I could factor out here and x squared and have negative 1/3 x plus 1. So the x-intercepts are 0 and 3. The y-intercept I would get by plugging in 0 for x, but I already have it because it's an x-intercept. The critical points are where the first derivative equals 0. And so those are going to be my maxes and mins. It's like critical points, relative maxima, concave up, concave down. Critical points are just going to lead us to those. So you don't have to be specific on that. F prime of x. How do I get, what's the derivative of this thing?
Therefore,
Negative x. So bring the 3 in front. Negative 3x squared over 3 is just x squared. Bring the 2 in front, reduce the power by 1. So now I need to set this equal to 0. And I'm going to do that by, I'm going to factor out negative x this time. So I know they're at 0 and 2 are my maxima and minima.
Big guy, say it though, say it. Big guy, swing about towards you. Big guy.
Now I will plug them into the original to get the y coordinates. 0, 0, 2 plugged in, -8/3 plus 4 is going, that's 4/3.
Wait, you playing Wobble Delilah? Please. No, Wobble. No, it's not. It's not. Canada.
Um,
It's not.
the first derivative test I can text increasing, decreasing, etc. So I plug in like -1 and I get a positive there and a negative in this part. So that's negative. That means it's decreasing. Plug in something like 1, I get a negative here and a negative there. Two negatives make a positive, right? Plug in 3, I get a negative and a positive, I get a negative again. So it's got to be decreasing, increasing, decreasing. It does ask me to get concavity. So I take the second derivative. Set that equal to 0 to get my inflection points. And that's x equals 1. To get the coordinate, I plug that into the original. -1/3 plus 1 is 2/3. So this is my point of inflection.
I hate.
If I plug in 0 to this, I get a positive. If I plug in something like 2, I get a negative, meaning this is where the concavity switch is. It's hooking down. So it's decreasing to here, increasing. This is all concave up. This is all concave down. It's a cubic. Does that make sense? So you think about the thing, ANI2, ANI2. Voice levels, please. So you start thinking about, your general shapes, cubics, are doing this, or if it's a negative, you switch it, which that one is. Quadratics, parabolas, quartics, parabolic things, but might have some extra things in the middle. Okay. Those things kind of make sense. So when we're doing this curve sketching, remembering your basic functions from pre-calc is helpful. It adds to it. I probably could have done this all by knowing it's decreasing over here, then it's increasing, then it's decreasing from there. I've got my x-intercepts, my inflection point gives me quite a few points that I'm tracing it through. Okay?
I think I missed it when you said 0.03 cool.
Oh, that's from the x-intercepts.
Oh, right.
So x-intercepts, I factored the original x equals 0 and 3
Okay.
from factoring the original function. And it tells you to find the y-intercept. Well, 0, 0 was the y, was an x and y. Because remember, from pre-calc, I also knew that it was going to bounce off there because 0 had a multiplicity of 2. Although knowing that it was a minimum also meant it had to turn. So the calculus is almost giving you some of the stuff. You take the calculus of the pre-calc, and some of it you can know from one or the other. You don't have to have both. But when you put them both together, it makes you pretty sure of your curve. That makes sense? Like this, I could have made a pretty rough sketch of this with just my pre-calc knowledge. Having this, knowing it was a negative cubic, it would not have had the maximum point. I wouldn't have had the inflection point, but I could have gotten pretty darn close without even any of this. But this confirmed that it's got to bounce off there at 0, 0. This one gave me the max. This one gave me the inflection point, which, well, it was halfway between the max and the min, which is pretty common. I'm gonna look through the rest of them and make sure you don't need anything more. Yeah, that's similar polynomial. This one's a rougher derivative, but it's the same effect. Well, here you have a rational function. So remember, with your rational function, you've got to find the vertical asymptotes.
So.
You're gonna want to find your end behavior asymptotes. And you can look and go, does it have any of those? The one on the test is gonna look like 1 and 2. Okay. That's it for today.
Thank you.
Mhm.